Ever wonder what it really takes to move a piece of sophisticated technology from one country to another? It's so much more than just shipping a box. And when that technology is life-saving medical software, well, the whole process is less like a delivery and more like a delicate, high-stakes operation. You could call it a digital transplant. And that brings us right to the heart of this explainer. How exactly does a complex medical imaging system, developed in Korea, get up and running to save lives in a hospital in Vietnam? As you're about to see, the answer is a total masterclass in planning, in training, and, crucially, in translation. So let's dive in. So yeah, our story really starts with this idea of a digital transplant. That's the moment a piece of software gets woven into the fabric of a new hospital, becoming its digital nerve center for literally every diagnosis that happens. Now, the tech at the center of all this is called UBPCSZ. The easiest way to think about it is like a hospital's super-powered library and viewing station for every critical image. We're talking X-rays, CT scans, the whole deal. It's the system that lets doctors instantly pull up, analyze, and share patient scans. It is absolutely fundamental for modern medicine. Okay, so let's meet the key players in this story. The software itself, UBPACS-Z, is made by a company called UbCare, based in Seoul, South Korea. And its destination? The Phanica Hex Health Center, all the way in Vietnam. Right away, you can see this is going to be a journey that crosses not just borders, but cultures, languages, and completely different technical landscapes. So how in the world do you pull off a project this complex? You don't just, show up with a laptop and hope for the best. No, it takes a ridiculously detailed plan. In this case, a 7-week blueprint that laid out every single step of the way. And just look at this timeline. The pace is just wow. It kicks off with training in mid-August. A week later, they are already on site in Vietnam installing servers. By week 4, they have a pilot program running. Just 2 weeks after that, it's the official launch, and by week 7, the whole thing is handed over to the local team. That isn't just fast, that is surgically precise. A timeline on paper is one thing, right? But making it a reality means you have to transfer some pretty deep knowledge. So this is where the project moves from the blueprint into intense hands-on training for the actual people who are going to build, use, and maintain this system for years to come. First up, you've got the local engineers. And this wasn't some boring webinar, this was intensive, hands-on work. They learned how to physically install the servers, how to connect them with all the different medical devices, and, this is so important, how to troubleshoot and fix the system when things go wrong. The goal was never just to install it and leave. It was to build real, lasting expertise right there on the ground. And of course, technology is only as good as the people using it every day. So the training had to be tailored for each specific role. If you're a radiologist, you're learning the really deep analysis tools to make a diagnosis. If you're a clinician, you're focused on how to quickly pull up scans and compare them. And if you're a radiologic technologist, you're learning the daily workflow of managing all that patient data. Everybody got exactly the training they needed, nothing more, nothing less. But here's the thing. You can install all the servers you want, and you can train the users perfectly, but that's still only half the battle. For this digital transplant to be truly successful, the technology itself had to learn to speak a new language. This next part is all about building that language bridge. And this right here, this is where the transplant really begins to take root. Just look at this. The software's interface completely changes. Study inquiry becomes tra Q ka chup. Now, this is so much more than just a simple translation. For a doctor in Vietnam in a high-pressure critical moment, seeing the interface in their own Mon Ngu Tinh Viet, their native Vietnamese language, isn't just a matter of comfort. It's about speed. It's about accuracy. It's about patient safety. And we're not just talking about a few buttons here and there. The team translated the entire user guide, the Hung Zen Suzyong. Every single function, every setting, every complex feature was made fully accessible in Vietnamese. This is the moment that technology stops feeling foreign. It's the moment that digital transplant is finally truly accepted by its new hosts. Okay. So the hardware is installed, the local teams are expertly trained, and that crucial language bridge has been built. All 7 weeks of intense preparation have led to this one single critical day. Go live. Now, going live isn't about flipping some big dramatic switch. No way. It's about going through a final, meticulous checklist. On that day, September 15th, the team confirmed absolutely everything: server stability, data flowing correctly from the other hospital systems, backup protocols. They even did final interviews with the doctors and staff to make sure everyone felt confident and ready. Only when every single one of those boxes was ticked did the system go fully operational across the entire health center. So it all leaves us with this one big thought. What this amazing journey from Korea to Vietnam really shows us is that for technology to truly succeed across borders, it has to speak a very human language. Not just the programming code it's written in, but the language of meticulous planning, the language of deep empathy for its users, and most critically of all, the actual native tongue of the people who depend on it to save lives.